learn the third formula. This is the last of the three formulas you have to learn about non-right angle triangle, which is the area of the triangle. Now, the area of triangle is very easy to calculate. So if you are given the angle C, you just have to do half times AB sine of the angle in between. Okay, so let's do an example. So if I want to find this area, I just have to do area is half times 5 times 7 times the angle in between. That's it. That gives you the area. So that's the easiest of the formula. So we can calculate the area of this triangle. So using a calculator, you will get 0.5 times 5 times 7 times sine of 50 degrees gives you 13.4, correct to 1 decimal place. Okay, any questions? It's pretty straightforward. So this is a useful formula when you don't have the perpendicular height. So if you don't have a perpendicular height, use this formula. Okay. Now on the other hand, if you know the triangle is a right angle triangle, it's easier if you just use half times base times height. Because you know this is the height, this is the base. So let's work it out. And what would the answer be? Half times 6 times 8. So if you halve the 6, you get 3. 3 times 8 is 24 square meters. Now the question is, does the other formula I just showed you, does it work for this case? It also works. Let me show you how. So what you could do is you can go, area can also be found doing half times 6 times 8, sine 90. Remember what sine 90 is. So you get the same thing, which is still 24. Okay? But this is a longer way to do it. It's better to do it with half times base times height if you know the perpendicular height. Okay. All right, once we do that, we'll just do a slightly different question where they give you the area. They want to find the missing side. And that's easy if you just set up an equation. The area is 70 square centimeters equal to half times 11 times x sine of 93. Like that. So you're going to work out what x is. So what you need to do, to solve for x, you can double both sides. So you get 140 equal to 11 sine 93x. So you multiply both sides by 2. Cancel that one. And then to find x, you just have to divide 140 by 11 sine 93. Using our calculator gives you 140 fraction 11 sine 93. Right? Make sure you close the bracket if you put it inside the denominator. Press equal, you get 12.74, 2 decimal places. And we've got one more page today as well, 12. We want to do some proof as well, so that you know where these formulas come from. Alright, that's in centimeters. Okay, good. Any questions? Pretty straightforward. Area of the triangle. After this, we're going to do some proof to show where these formula come from. All these formula come from using SOHCAHTOA and some Pythagoras theorem. Let me show you how to do this. Formula, and they're not very hard to prove, so let's prove the area formula. The area is quite easy to do. For example, to get the formula area, you just have to go base times height, isn't it? So you go half times A times H. But we don't know what the height is, so we can figure out using sine. So what you do is, using this triangle, you can work out what sine is. So you can write H over B equal to sine C. So therefore H, the height is B sine C. That's where the sine comes from. The height is B sine C. That's your formula, half AB sine C, area of the triangle. So it's very easy to prove. So this is really coming from, so this formula for the area of triangle comes from base times height. But because we don't know the height, we rely on the angle C to work out the height. But you don't have to think about the height, you just remember half times A times B, sine of the angle in between. Okay? Alright, any question? Now why do I do this formula first? Because once I do this formula, I could use it to prove this formula, the sine rule. Where does that come from? I could prove it using area. Okay, let's show you how it's done. Let me see. So we're going to use the same triangle, and we're going to prove this formula. Okay, so let's rub off. So to prove this formula, we're going to do the following. We're going to find the area of the triangle in 3 different ways. So we can find the area of the triangle, ABC, which can be done half AB sine C. Or I could choose a different side, so I could choose half BC sine A. Or I could choose a different side, half AC sine B, right? Because I could find the same area using 2 pairs of sides. And there's 3 different ways to do that. I could do AB, sine of this angle, BC, sine of A, or CA, sine of B. Okay, so we can find the area of the triangle in 3 different ways, giving you the same answer. So what we're going to do is, the first step is to multiply everything by 2. Cancel, 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 like that. So we've got AB sine C equal to BC sine A equal to AC sine B. Right, write that down. So we'll multiply both sides by 2 to get rid of the half. And the next step is something not obvious, so we're going to do that. So what you're going to do is, I'm going to get rid of the AB, BC, and AC all at the same time. So what we do is, let's divide by everything. ABC, you got to do the same side on both sides of the equation. Okay. So you're going to work out the AB get cancelled, the BC get cancelled, and the AC get cancelled. And what do you have left? You have this sine rule. That's where the sine rule comes from. That's why I do the area first, because it's very easy if you do it that way. And there's other way to prove that. You can have a look at the textbook, see how it's done. There's other ways. There's different ways as well. Check textbook if you're interested. I'll prove the sine rule. The cosine rule is a little bit hard to prove. There's exercise in the textbook we could try. I think it's in the enrichment. But let's go through it anyway, because it's quite interesting. Okay, so write it down. Alright, so cosine rule is a little bit algebraically more challenging. So let's go through that. Okay, let's look. It's the same triangle. What we're going to do is, like before, we have to rely, all these proofs rely on a right angle triangle. So I have to draw a perpendicular height, call that H. Okay, we've got perpendicular height. Alright, so let's repeat. Let's show you what the cosine will look like. C squared equal to A squared plus B squared minus 2AB cos C. Like that. Okay, so what you're going to do, let me try to think. Alright, so what we could do is maybe call this side X. Right? And this side will be A minus X. Right? Because the total length is A. Now all this proof is not examinable, you just need to remember the formula. But we'll just do it for so that you know where the formula comes from, and it's actually good mathematical exercise. So we're going to continue. We're going to use Pythagoras theorem. As you can see, that reminds you of Pythagoras theorem. So we're going to go c squared equals to h squared plus a minus x squared, right? Pythagoras on this triangle. C squared equal to h squared, a minus x all squared. And what you need to do is to expand. So you go h squared plus a squared minus 2ax. Hopefully you remember the stuff from chapter 8, how to expand perfect squares. Right, so you write the Pythagoras theorem, write down expand a minus x to perfect square. And what do we do after this? We have to rearrange a little bit. We know a squared should go first, followed by h squared plus x squared, and then minus 2ax. Okay, so rearrange it so that it's in this order. Now, we need to make it look like this. Now, it doesn't look fully like that, but we've got the structure there. We've got the a squared already. We've got the c squared. We've got the minus there, but we don't have the cos yet, and we don't have the b yet. So we have to introduce b into the formula. And to do that, we're going to use this triangle. Let's do Pythagoras theorem on that. B squared equals to, so let's write it in black pen, b squared equal to x squared plus h squared. And that's already here. That's your b squared. So I could insert b squared in this space. Right? Minus 2a. Now how do I get rid of the x? We get rid of the x by looking at the same triangle again. In the same triangle, I could go cos c equal to adjacent of the hypotenuse. So therefore x equal to b cos c. That will help you to replace this xc by b cos c. And that's your cosine rule. So a little bit complicated. The proof is a bit hard, but do not worry, that won't be tested, but it's a good thing to learn. Especially if you're thinking about doing extension 2 or extension 1, you should learn this mathematical technique, because it's good thinking skills. Because in year 11 and year 12, you'll be doing something similar, not this proof, but some other proof, if you're thinking about doing extension 2 or extension 1. Okay, but otherwise the emphasis should be memorizing this formula, and memorize this formula. All three formulas. Let's use a highlighter. So today's exercise will be exercise 7i. Now, if you don't have time, you do it, and then you finish in the holiday. Last holiday, a lot of people didn't use the holiday to finish work. So